Okay, we got one final video we're going to look at. The first one is when given the odds in favor, the odds against, to actually calculate a probability from that. So we're kind of going in the opposite direction of actually finding odds. And then the last thing is actually calculate what's called expected value. Expected value is an easy thing to calculate, and we'll see that here in just a second. Alright, so looking at number 11, number 12, it says the odds in favor of a horse winning a race are posted as 4 to 3. Find the probability that the horse will win the race. Okay, now to calculate this, there's really not a whole lot of math really that we can do. It's just basically having to understand how odds are created. Well, we know that the odds are created by probability 4 divided by the probability against. Okay, and then that somehow for this particular problem works out to 4 to 3. Okay, and so we know then, and let me skinny up my line even further if I can, we know that means that there's some fraction, a compound fraction specifically, that has a 4 and a 3. Okay, but what number goes as the bottom or the denominator of both of those fractions in that bigger fraction? Well, if this number is 4 and this is 3, those are the totals of together. That's the total of how many possible occurrences you could have. So we know these have to be 7s. Okay, these two numbers will add up to the total number of possibilities, and so we've got a fraction divided by a fraction. Well, again, knowing what this means, this is the probability for something happening divided by the probability against it happening. And so they're asking, what's the probability that the horse will win the race? 4 7s. Okay. Now, knowing what we know now, we can approach number 12. The odds in favor of a horse winning a race are posted as 8 to 7. Find the probability that the horse will lose the race. So again, they're trying to be a little tricky here with the whole losing the race thing. Okay. So be careful with that. Okay. And so and without having to do all this stuff we did here, we look at the two numbers we have, the 8 and 7. That gives us our bottom number. And then the first number is the odds in favor. The first one is the odds against. Okay? And so the odds that the horse will lose the race, or the probability he'll lose the race, will be 7 over 15. Okay, so pretty straightforward stuff. Again, really having a good understanding of this will actually put you in good position to be able to figure that out. Okay. Again, you don't have to do this every time, but maybe it'll help to kind of walk your way through all this to get to this point. Okay, good stuff on top, bad stuff on bottom. Okay. Now, expected value. Expected value is basically it gives you a notion of what you can expect to win in a certain situation. Okay, you're probably going to need a calculator for this, and this is probably the only thing you'll need a calculator for on this whole thing. Hopefully you've gotten your scientific calculator. Using a phone, you're not really supposed to be using a phone, and I certainly recommend any Texas Instruments scientific calculator you can get your hands on. So expected value is denoted by an uppercase E. And so what you would do, there's probably going to be two, and the problems we do, there'll be two pieces of expected value. Okay, and before we talk about what those pieces are, let's look through what our problem tells us. Okay, it says suppose you buy one ticket for $1 out of a lottery of 1,000 tickets. The prize for the one winning ticket is to be $500. What are your expected winnings? Okay, now we spent $1. Okay, so we were out $1. Okay, so that's basically -1. Okay, and out of 1,000, okay, we've got a 1 in 1,000 chance of winning that $500. Okay, and then what are your expected winnings? Okay, well, what we have to look at in that is specifically, basically, that we've started even. We started with nothing, okay, and then we spent, and I know that's kind of counterintuitive, but by spending $1, we've put ourselves to the negative. So, when we set up expected value, I'll get my calculator right. Okay, the first thing we want to have is we want to figure out what is the probability of winning this particular drawing. Okay, for us, because we bought one ticket, it'd be 1 out of 1,000. Okay, now that is the probability of us winning. Okay, is 1 in 1,000. And we want to multiply that by how much we can expect to win if this happens. Well, a 1 in 1,000 chance has us winning $500. Okay? Now, the next thing we have to do, because we have spent some money, what's the probability that we're going to be out $1? Okay? Well, we spent 1 in 1,000. The probability we're going to be out $1 is 999 out of 1,000. That we're going to be out $1. So -1. And so you be careful with that. When you do these expected values, you're going to have a negative in there from what was spent. Okay. Now this can then go into your calculator just like what you have. Okay. And so your 1 out of 1,000 times 500 plus your 999 over 1,000 times -1. Gives you -499 over 1,000. And then to calculate that on down and simplify that, your expected value, or what you can expect out of this, is to be out 49 cents. Okay, so -49 cents. Or you can round it to 50. They may ask you to round it to 50. Okay? So the probability of winning plus the probability of not winning. Okay? And again, why is this negative? Well, because your expected value here is to lose money. Okay? And the reason why is because you just bought one ticket. Okay? Now if you'd bought more tickets, that would make this number go up, would give you a bigger piece of this pie, and then it would decrease your number here. Remember, the closer these two numbers are to each other in a fraction, the bigger the fraction is. Okay, so you got this big heavy number here being multiplied by a negative. This itty bitty number multiplied by the positive. Even though this positive is a big number, this is heavy too, pulling on that negative to help you lose more money. Okay, so looking at this next one. This next one is structured basically the same thing. Okay, suppose a charitable organization decides to raise money by raffling a trip worth $500. If 3,000 tickets are sold at $1 each, find an expected value of winning for a person who buys one ticket. Okay, so again, probability of winning. Okay, 1 out of 3,000. So there's a 1 in 3,000 chance I'm going to win the trip worth $500. But then there's a 2,999 out of 3,000 chance I'm going to be out $1. Okay, now that of course would change if these raffle tickets were $5, that would be a -5. Okay, again, that negative denotes that money went out, okay, that we didn't keep it. Okay, so 1 in 3,000 times the 500 plus the 2,999 divided by 3,000 times -1 gives us negative 83 cents. Excuse me, that's a horrible way. So negative 83 cents. Okay, so expected value, again, pretty straightforward stuff. Now this could get bigger. Some of our expected value problems could have 3 or 4 different pieces. The ones we'll do will just have 2 basically. One piece will be the probability of winning something, and then the other aspect or the other piece will actually have how much money was spent. Okay, that is the end of the probability lecture, and that's about how long it would take if we was actually meeting in class. You can go ahead and start working through the homework and the quizzes. We'll meet next week, Thursday the 12th, and we'll start at 6 o'clock. If you have any questions this week, make sure to email me, let me know. Get logged in to my math lab, and those homework assignments are posted, ready to go right now for you to go ahead and start on. And if you have any questions, let me know. Have a good week.